cosine curve. And it has to do with using our points on the unit circle. Last year was kind of a different year. Some years Mr. Staubin has to put huge sheets of graph paper out. Did you do that? Okay. And so I don't know if you remember when you did that, you used some of those exact measures and you plotted points and they get the curves. So the one key thing I want you to remember is these are not like V things. When I draw these points, I'm drawing a smooth curve through them. For sketches, what I would like you to do, we'll start with sine, is I would like you, and I'm going to use my little, you feel free to grab rulers too if you like that. I'm going to make my y or my x-axis, and on the x-axis I'm graphing the angles, okay? And then I'm going to graph over here, and just for the heck of it, I'm going to make this a 1 and a -1, so it's just a nice picture. Okay, once you have that, then I'm going to tell you my little trick. By changing numbers in the sine curve, we can change the length, the amount of time it takes for something to go around. How long does it take to come full circle for these things? What's one rotation? 360, but 2 pi, right? So when you're graphing, what happens is it goes 1 cycle in 2 pi. So somewhere on your axis, would you put a 2 pi? Just label it. If you always start by putting the period of your sine or cosine curve, this is the easiest way to sketch graphs. Take that 2 pi. You're going to cut it in half twice. So I cut it in half. That's pi, right? And cut each of those in half. Sometimes when you get a funky different period, you might not know what the fractions are, but keep that model of cutting in half and then cutting in half again. And then what I'm going to do is I'm going to start the sine at 0, 0. Why? Because the sine at 0 is 0. Remember, it's the y coordinate, right? So I start it here, and then at each of the perfect points I picked, then it's going to go up to its max, so up to 1. Then it comes back down to the middle, down to the minimum, so -1. And those points just help me draw that cycle. So here's the sine curve cycle. What would happen after 2 pi? It'd do the same thing again. So if you want to put a second period on there, you can. It would now be 4 pi. Remember, I cut it in half. If you want, just tick marks on there. And I cut each of those in half to kind of help guide me through. Now where would it go? Up to the max, back down to the middle, down to the min, and so on. So I just sketched 2 cycles of my sine curve. What would happen if I put a number in front? Anyone know? Let's say I put a 5 in front. All that would do is it wouldn't keep my period it wouldn't make that any different. What it would do is it would stretch these points to up to, what did I say again? 5? 5, up to 5 and down to -5. So putting a number in front doesn't change anything you do on this axis. It just changes those highs and low points. Okay. All right. Let's sketch cosine. So we're going to start off the same way for cosine, and then I'm going to show you how we just actually start the cosine in a different spot. The process is no different. So I want my x-axis again. And I have 1. I'm going to try my best to line up what I picked the same. Okay, so I'm going to put my period on again. Same period, 2 pi. What do I do with this again? Cut it in half. And then cut it in half again. So a cosine curve, instead of going through 0, 0, goes through its maximum. In this case, it goes through 0, 1. So we started sine at 0, 0. We're going to start cosine at 0, 1. So what is it going to do now? I started it at its max. What's the only thing it can do? Now it's going to start by going, same idea though, goes down to 0, down to -1, back up to the middle. So there's one cycle of your cosine curve. And then I'm going to repeat it. And once you start to get really good, you don't even have to do the points. You can just kind of draw the curve. Okay, so as I mentioned before, if you took the sine curve and you moved it to the left by pi halves, it would be the cosine curve. Or the other way around, if you took the cosine curve and you moved it pi halves to the right, it would be the sine curve. Or you could move it lots of different ways. You could move it more than that because it's cyclical. So, okay, so what happens? So you said you did this, right? You did some sketching before. So all we're going to talk about today is changing around the amplitude. Have you heard of that before, what the amplitude is? Amplitude is like the height of a wave. And we're going to talk about also changing the period around. We're not going to do any other shifts until tomorrow. So what I would like you to write in your notes is an equation. We're going to take the time to do it about anything that could happen to a sine curve. So what we're going to write down is f of x equals a in front times the sine, now put a big parentheses, of b parentheses x minus h. Would you close then both parentheses plus k. This becomes pretty important that you know what these things do, so I'm going to just go piece by piece. This number in front, think of transformations. Wasn't that like a vertical stretch or shrink? It does. It either makes the wave higher or lower. We call it the amplitude. So the absolute value of that number in front is the amplitude. Okay. I don't know if you remember that x is a liar. So even if I multiply x times a number, like let's say it was a 3, what that does is actually compresses it horizontally. So if you want to figure out what the period of a sine or cosine curve is, and there's a b in front, all you do is you take 2 pi, because that's the original period of a sine or cosine curve, and you divide it by the absolute value of b. And that will give you the period of your new function. when you flip the period around, this isn't that big of a deal, but it's called the frequency. Think of it as this, like it's how many cycles it goes per time unit. So if you flip this around, if I ever ask for the frequency, it's just the reciprocal of the period. We are mostly going to deal with these today, these three. Okay, who remembers when you subtract something from x in an equation, do you remember what it did in chapters 1, 2, and 3? It moved it. Which way? Don't remember. Up and down? Left and right? Left and right, okay. So this H is just a horizontal shift, and we call it a phase shift. I don't really care about that. Just realize the book calls trig functions, they call them phase shift. It just means that it's horizontal though. And this K, what does that do to the function? Up or down? We call it then the vertical shift. Okay. So let's just do one where we figure out what those things are, and I'll show you how to sketch your new graph. I'm going to do it. I was deciding if I was going to do it in my notebook or not because I want these things on here. I'll do it on a piece of graph paper. Yeah. Yep. Okay, I'm going to give you one, and then we're going to identify the amplitude and period, and then I'm going to show you how you can sketch your new graph using that little technique that I taught you at the beginning of class. So let's find the amplitude and period of f of x equals 3 sine of 2x. Keep in mind today, if I ask you just to find these things, you're just using what we wrote, the ways to find them in our notes. You don't need to sketch a graph unless I tell you to sketch a graph, and I didn't ask you to on all of them. So let's go to this. Remember, the amplitude I find right in front, and the period I find by identifying what x is multiplied by. All right, so what's A in this case? 3. So my amplitude then, wait, what? Oh, this S? Amplitude is the absolute value of 3, which is 3. I don't really need to write that down. Just be aware if it was a negative, we don't say negative amplitude. It's just because it's the height of the wave. It's basically the height of one from the middle to the top of the wave. Period is normally 2 pi, but what I do is I figure out what the coefficient of x is. What's x multiplied by? 2. So that's my b. b is 2. So the period we said was 2 pi over the absolute value of b. So we would take 2 pi divided by 2. What's the period of this function? Pi.
Wait, how'd you get B?
B is what x is multiplied by. See right here, Delaney. I just didn't, we're not gonna do all of these things together. I'm only gonna focus on these ones, but B is what X is multiplied by. It basically either stretches or compresses it horizontally. So that makes sense. If the period was 2 pi and now it's pi, what happened? What happened? Got half as big, right? Shrunk half as big or compressed half as big. Okay. Putting it all together, remember my trick from before. If I asked you to sketch a picture of the graph, I said to put what on the graph? Do you remember? After I did the XY, what was the very first thing I put on my graph? I put 2 pi. Does anybody know why I put 2 pi on there? Because the period of the sine and cosine function is 2 pi. No longer is the period 2 pi. What's the period now? Pi. So now when you're sketching this, you're going to want to put pi on your graph. I'm going to put it right here so that I can cut it in half, which would be pi halves, and then cut it in half again. So now I have to do a whole cycle in 1 pi. Okay, here's the other difference. Before I started at 0 and I went up to 1. I'm still going to start at 0, but the amplitude is now 3. So what should I go up to instead? So I go up to 3. I made it high enough. So this is going to be steeper curves. Come back to the middle, down to -3, back up there. So it looks something like this. I could do it again. Let's see. One more. Keep going. It's up here. There. Let's see, that was pi. Now I'd be at 2 pi. So when I say sketch your picture of your graph, I really just want you to acknowledge at this point today that if the period changes and the amplitude changes. How would this graph look different if it was a cosine curve? Let's say this had been cosine instead. It would have started at 3 instead, but the cycle still is the same. How are we feeling?
Right.
Do you think you can try some?